Hey guys, it's Mrs. Kusalaba. We're talking about systems today. This is lesson 307. So the Ohio standards say that we have to learn about matter and energy and ways that matter and energy come and go. It can be transformed or transferred, but never lost. So your goal today is that you want to be able to describe what a system is, describe the words input and output related to a system, and compare and contrast an open, closed, and isolated type systems. As you watch today's video, make sure you take notes, and then you will have a 3.07 daily quiz today. All right, so let's talk about what a system is. In science, a system refers to any part of the universe that's being studied. If you're conducting an experiment in a beaker, for example, then the system that you are studying is in the beaker. The system is subject to surrounding factors such as the temperature or pressure or maybe some heat or whatever is being added to the system. But we look at systems to observe and measure any changes that are happening. And we use those observations and see what changes are happening to study some complex problems. So let's look at a few examples of what a system is. Okay, one example that we could study as scientists are we losing the ozone layer? That's something that scientists are always studying. So that would be an example of a system. The area above the Earth there that is getting rid of the ozone layer or seeing if it's being replenished. We want to study that. Another example of a system would be if Earth as a whole system is trapping too much heat with greenhouse effect. Another example of a system on Earth would be just one lake drying up. So maybe scientists want to know where the water is going. All right, so why is Lake Mead drying up as an example of a system that we could do observations on? A small example of a system could just be an aquarium tank. Maybe we have to have a certain amount of heat for our pet turtle, and we just want to see how to keep the heat from escaping our aquarium. So as you can see from those examples, a system could be really big, like the entire Earth, or really small as an aquarium, for example, or even smaller. Okay, so what we want to look at for our vocabulary today are inputs and outputs. You probably already know the words matter and energy. Just to review, matter is any substance that has mass and takes up space. So anything that you can think of, air, water, stuff, molecules, anything made of atoms and molecules. Energy is that ability to do work. There's lots of different types of energy, but the input is what's put into a system to help it do its job. Okay, so if the system, for example, is the lake, maybe we're looking at how much water is put in, how much water is taken out. Maybe we're looking at the radiant or electromagnetic energy from the sun and how it's affecting how much water is going into that lake to dry it up. We also will look at outputs of the system. That's the stuff that's coming out of a system. All right, so in our little aquarium example, the output might be how much heat is staying in the aquarium. That would be the input. The output would be how much is escaping. And maybe we want the temperature just right on the inside. So we need to look at inputs and outputs of different systems to see if we can keep the system nice and normal, whatever that normal is that we're trying to achieve in science. All right, so let's look at these different examples of systems. We're looking specifically at a car engine. We're looking at an orchestra, a digestive system, and a can opener. For each one of these, what matter or what energy would be needed to be input in each one of these systems? Pause the video for just a second. Write down some examples of each one of what would needed to be added to the car or car engine to get that car to work. what would be needed for the orchestra to be able to play their music? What would we put in to make the digestive system work? And what needs to go into the can opener? All right, hopefully you had a second to pause the video and think about these on your own without me giving them to you, but let's take a look. So a car engine definitely needs gasoline, doesn't it, to work? So that would be a chemical energy, gasoline, that would need it to be input for the car to even move. Okay, mechanical energy are the actual movement and blowing of the wind across our instruments would be needed in this particular system. Again, food would be needed to do the digestive system work. So that would be chemical energy would be an example of an input that goes into the digestive system. And then the can opener as a system, we'd have to put in some mechanical energy and really move our arms and our fingers and hands to get the can opener to open. All right, so those are things that are input into these different systems. And remember, system can be really small, like a can opener, or it can be really big, like the entire Earth. All right, let's look at outputs. Can you think of what outputs would come out of the car engine as a system, or the orchestra, the digestive system, or the can opener? Think this time of what we're getting back out of each one of these items. Pause the video for a minute and see if you can write down your own thoughts. Okay, so remember, the input and output is going to be matter, like a substance, or energy, something that's doing work. So we're getting mechanical energy from a car engine, meaning the car moves. Maybe we're getting some chemical as well. Think about the exhaust coming out of the back of the car. That's definitely something that is an output from a car engine. All right, what about the orchestra? Did you say that you're getting sound energy out of that system? All right, the digestive system, maybe we're getting some heat, that's thermal energy. Some movement of the food, that's mechanical energy. And we're changing all of that food chemically and doing some chemical reactions in there, so we're getting some chemical energy as well. All right, the can opener, maybe we're getting mechanical energy as an output as well as we actually cut into a can. So there's energies coming out and in, there's material or matter coming out and into systems. So remember, there's different inputs and outputs that we get from any system. We get matter, input or output. We get energy that we have to put in or put out or get out. I mean, we have different forms of energy here that you can pause the video and read. Sometimes the input from one system can be the output for another system. For example, the output of an apple tree is going to be the apples. But when we take the apples in, or it's an input into our system, our digestive system, gives us some fuel. All right. If you had to, could you label the inputs and outputs of a tea kettle? What matter is going into a tea kettle to make some tea? What energy has to be added to get that water to heat up? Okay, and then after the water heats up, what comes out of a tea kettle? All right, let's take a look at this picture here. What is the big difference between these two pots, ignoring the size, the shape, the color? What's the one big difference between this one here and this one over here? All right, hopefully you said there's a lid on the one pot. How would that affect our system? So we have what's called open systems and closed systems. Can you tell which one of these two pots would be an open system and which one would be closed? I bet you can. All right, so an open system would be where we have no lid, the matter and the energy is free to come and go as it pleases, right? There's no lid on it. no covering up to keep the matter and the energy inside of that pot. Okay, so the energy and the matter from the system is being added and removed. Oops, spelled matter wrong there. So let's take a look at open system examples here. If we had some plants growing, the input that the plant would need to grow would be some light energy. We would need to put some matter in, like water, some minerals, some carbon dioxide to get it to grow. The output would be what comes out of the plant. What does the plant give us? The plant would give us some matter, like leaves and fruit. It would also give off oxygen and some new growth on the plant. So that's just one example of a plant system. In a closed system, we literally close the system with some type of lid. Now it can be a literal lid, or it could just be figuratively, right? Where nothing can escape. So there's no exchange of matter, but the energy is allowed to transfer back and forth. All right, let's take a closer look at what this means by watching a video together.
In the previous video, I told you that all chemical reactions involve energy being either released or absorbed by the system. And I defined the system as the chemical reaction that we're studying or any object that's under study. In science, we recognize three different types of systems: the open system, the closed system, and the isolated system. And in this video, I'm going to give you a definition of each of these three types of systems and explain how they're similar and different. An open system is the most common type of system that we work with in chemistry. And this system, as its name implies, is completely open to the surroundings. This means that the system can freely exchange mass with the surroundings. So it doesn't have a lid on it. It is not physically closed. Freely exchanging mass means that we could add more to that system if we wanted, or we could see that some of the system's mass was lost to the surroundings if that were the case. In addition to that, this system is also free to exchange heat or energy with the surroundings. So this means that we can heat this system up by maybe putting a Bunsen burner underneath it. Or if this reaction is exothermic, this reaction can give off heat, and if we were to touch it, it would feel warm. So let's write down a definition of an open system is one that can exchange both mass and energy with the surroundings. And again, as I said, this is the most common type of system that we work with in chemistry. Now, the second type of system that we're going to talk about is a closed system. And in the closed system, we literally just close it up. We put a lid on the top of it, or we put a stopper inside this flask. Putting a lid on the top of it means that it is no longer free to exchange mass with the surroundings. So whatever we have inside of this container is not going to come out. So it cannot exchange mass anymore, but it is still free to exchange energy with the surroundings. As we talked about with the open system, this means that we can heat the closed system up by putting a Bunsen burner underneath it or setting it onto a hot plate. Or if this is an exothermic reaction and we touch it, we'll be able to feel the heat or the energy that is being given off by this process. So a closed system, if we define that, can only exchange energy with its surroundings. Now, the final type of system that we're going to talk about is an isolated system. And as you kind of imagine watching the progression of how this goes, an isolated system is one that is completely, as the name implies, isolated from its environment. So that involves putting a lid on this so that no mass can get out. So we're closing it up so that no mass can be exchanged. And in addition to that, it involves putting some sort of insulation around this system. So I'm just going to draw some sort of insulating device here. Maybe we'll shade it a little bit. This is some sort of insulator that prevents the system from exchanging energy with the surroundings. So I'm going to label this that it is insulated. The types of insulation that we would use for this depends on the system itself and what we're actually trying to accomplish. In this isolated system, because it has this lid on it, it cannot exchange mass with the surroundings. And also because of this insulation, if any heat is being given off by this system, it is not going to be allowed to escape into the surroundings, or vice versa. If we were to put some sort of Bunsen burner underneath this, the heat from that Bunsen burner would not be able to make its way through the insulation and get into the system. So an isolated system is one that cannot exchange anything with the surroundings. And these are the three different types of systems that we work with in chemistry. The open system, which can exchange both energy and mass, the closed system, which only exchanges energy, and the isolated system, which does not exchange anything at all.
All right, need to know for your quiz today. Let's talk about Earth as an open or closed system. If I said that Earth is a closed system for matter, pause the video for just a second and think about what that means. What matter is trying to escape Earth, or what matter is trying to get into Earth? Okay, well, the Earth is made up of those chemical elements we've already talked about, the ones on the periodic table. Because of gravity, matter does not leave Earth as a system. It's like a closed box because gravity keeps shoving things back down to Earth. And the laws of thermodynamics, long agreed by scientists, they tell us it's impossible to destroy matter. So the matter that we have on Earth will always be here. All right, so we have matter on Earth and it's staying on Earth. It's considered a closed system for matter, guys, because of gravity. It just can't leave the atmosphere. All right, and then the Earth is an open system for energy. And let's think about that for a second. This is really easy, guys, to think about. What energy is coming into our atmosphere? If you're reading ahead, you're probably on the ball here. The sun, the sunlight is the type of energy that comes down in here to Earth. Energy can be radiated back out of our atmosphere. And the flow of that energy is regulated by Earth's atmosphere and our ozone layer. And this delicate balanced transfer of energy maintains our surface temperature here on Earth. Without it, we wouldn't be able to live, would we? All right, so think about that. This is a question on your quiz today. Earth is usually thought of as a closed system, especially when you're talking about matter. Because of gravity, matter just doesn't escape and drift off and float up into the air and out of our atmosphere. However, the sunlight, which is a form of energy, can come and go, can it? All right, guys, if you have any questions, make sure you reach out to your science teacher. Have a great rest of your day.